Ladies and gentlemen, I would like to welcome you to this session, Infrastructure for Collaboration. My name is Bartłomiej Dzikowski. I am from Poznań Supercomputing and Networking Center. This session concerns different approaches and aspects of distant cooperation. We'll have three presentations during this session. The first one will be done by Zdeněk Travníček from CESNET and Czech Technical University. Zdeněk works for CESNET as a software developer in projects involving streaming of video in high resolution and collaboration. He also works in Czech Technical University in Prague, where it's responsible for cave system. Zdeněk, please.
Do I need to use some? Oh, it's fine. Yeah, it's okay. So, good morning, everyone. My name is Zdeněk Travníček, as Bartłomiej said before, and I'm here on behalf of CESNET, and I'm supposed to talk about our experience with some stereoscopic picture transmission for remote collaboration. I will say you at the beginning what is it about, and then I will come to the practical experience. So, in many areas recently, people use some visualizations of their data. It might be in research, it might be in industry, lots of architectures or artists are using visualizations, and also when you teach, you usually visualize your data. Recently, it's more and more usual to use some immersive visualizations like cave systems, or less immersive like some 3D projections or 3D screens. But once you start using these projections, you usually end up wanting to share your visualizations or share your data with your colleagues, your clients, or other people you work with. And you basically have, you have several possibilities, but the two basic ones would be you can just give the data to the other party. That's easy, that's fast. It usually doesn't need large bandwidth to do it. But from our point of view, there are at least two problems. First problem is in the technical part, when you have to force the other party to use the same software you use, and if you want to show them the same thing you look at the same time, you have to have some, let's say, better visualization tool to synchronize the visualization or the view on the scene. Another problem, which is maybe more important, is the, let's say, legal problem and intellectual properties, because usually most of the companies don't like to give their data away. So the solution we use, or we are working on, is basically to share the already finished visualizations. We do not give the data to anyone. We have data at the source location all the time, just visualize them, and then send the already finished visualization as a video stream to the other side. This usually satisfies the people who take care about the intellectual properties. But the biggest drawback of this approach is that it needs quite large amount of data, basically high bandwidth. But most of us here do have access to high bandwidth usually, so it's not a big problem. And so what we do is that we are trying to provide to share the visualizations in an interactive way. So it's not only like streaming video from one party to another one, but we also have the infrastructure to allow the remote party to control the scene we have on the source location. And due to it, we are able to, accomplish or establish the collaboration between several teams as I show you in the second part of the presentation. There are basically two configurations we use to accomplish this task. The first one is based on MVTP4K, which is a hardware platform developed at CESNet, which has a very low latency for processing of the signal. It should have under 1 millisecond of latency, or it should add only less than 1 millisecond of latency for the processing of both sides together. And it does not depend on the resolution or anything. It's just really streaming the data, doesn't care what the data is, and has very low latency. If you just want to show the data, it is the lower part of the picture. You basically just put the two boxes, connect the source, connect the output, and it works. But as I said, we want to have some interactivity, so we also have to have some tracking device or some input device. And when we have it, we just install a very small piece of software on the controlling device or controlling PC and stream it together with the data and have some techniques to seamlessly integrate it with the applications or on the source. This method is very, very nice for streaming. The biggest problem for us is that basically the box needed or needs the resolutions supported by SMPTE, which means some like television resolution for us. For example, we use, where I work, we use a cave system, we use active stereoscopy, which means refresh frequency of 120 Hertz, and that's not very usual resolution, and it's very hard to stream it this way. So the solution I would like to talk about or show you the examples of is our combined software and hardware transmission of the data. We usually get a larger latency using this solution, but it's not as large. Well, it's not too large yet. The processing on the sending side only usually fits under 50 milliseconds, but it really depends on the resolution and other stuff. The network delay is obvious, and because of the nature of software, which just cannot be guaranteed to be really exact, we have to employ some buffering and like optional sizes. Usually it's enough to buffer like 10 milliseconds, but we are able to buffer up to, if I remember correctly, half a second on the receiving side, even though buffering half a second wouldn't kill the interactivity at all, right, completely. The main point or main highlight of this solution is that it's closely integrated with the visualization software. It does not mean we have to modify the software. We just have our, let's say, daemon or part of application which is running before the visualization software, and it seamlessly integrates with the application and just gets the data when it's visualized and sends them without the application knowing what's going on. And again, we have some tracking device on the remote side, which basically allows us to control the remote scene without any problem. By using a software to get the data or process the data, we have possibility to modify the data in any way or to transform them in any way. This is a screenshot from a presentation we had, or demonstration we had several years ago actually, and where we are streaming data from a case system to just simple stereoscopic projection at approximately this size. So what we did is, when we wanted to show the people it's really a case system, we show them the main screen and edit the sides just to have the feeling of a case system. Even though the stereoscopic doesn't really work on the sides, right? It's not really possible. So the software part we use, basically the main highlights of this solution are the tight integration with the application. It means that we are usually using OpenGL applications, and when the application is ready, it says, okay, I have the data ready to the graphic card, and it sends them away. We hook here, and before the data are sent to the screen, we get them and stream them. So actually we process them a bit before they are shown locally. And yeah, the most interesting for us, the very important part is the compatibility with MVTP 4K, because we are using it as the other part of the box. So, for the second part, our practical experience. Firstly, we presented this solution last year at Terena in Prague. It was basically a transmission for a very short distance, or on a very short distance. It was from lab in one part of Prague to the hotel in the other part of Prague. So there was kind of negligible network delay for it. It didn't really take into account. So we could afford a bit higher buffering on the receiving side. And at that time, we didn't really have any applications to show. So it was just a testing application we had in the case system. But still, the users who tried it, I know maybe some of you actually did, could move in the scenes which were rendered in our cave, and they saw the result immediately, and all of them agreed that basically they didn't feel the network delay or the delay at all. So it felt like they were controlling the application locally, even though it was rendered, I don't know, like 20 kilometers away. But more interesting demonstration is from last year's Cinegrid in December in San Diego. And on this map, I don't know if you really can see it, but the source was the same. So it was our case system back in Prague. And the other part, or the remote part, was in University of San Diego in San Diego. And basically we did very similar things. It was the same setup as before. I'll show you some details. And we also have video conference system just to show it's really live and to be able to talk to people on the other side, even like independently on our system. And what we did was that we showed two demonstrations. First one was some collaboration on, well, developing an architectural model of city. Basically, it was a bit fake. It wasn't fake, but it was like not really real life, because we had to play it a bit. But we tried to show how two people are just working on a model of city and deciding what kind of building should be placed on a free lot. And, well, it went like the guy on the one on the side in the cave was just going through the city, telling us what's going on, and we were able to see it like as a movie. But afterwards he said, okay, so let's control it. We took our gamepads and we were able to control the scene naturally from the other part, and it was still very easily controllable. Even though it's quite far, as you can see on this picture, it's basically, well, not half of the world, but quarter of the world, which was like 10,000 kilometers one side. So it means the network latency was around 100 milliseconds one way. And we had to take in account both ways, because we get the data from the input device, stream them back to Prague, process it, and stream it back to San Diego, which means that only the network delay was doing like 200 milliseconds. But the rest of the processing was quite fast, so we were able to fit into like 250 or 300 milliseconds completely. Well, on this presentation, we just wanted to show that it can really help two remote teams to see it, and that it's quite, well, important to be able to share the point of the view of the scene, because it doesn't really have sense if one is, the guy on the other side is saying, okay, here is a nice lot, let's build a building, and we don't know where it is. The second part was walkthrough of a digital model of Prague, which is quite old, like 200 years old, built by Antonín Langweil, like in 1926. He started 1926 and continued for like 11 years. And the reason we showed, and this model is a collection item of City of Prague Museum, I have to say this. This model is it's really interesting model. It's nice paper model of Prague, which was built, as I said, a long time ago. But well, because of the intellectual properties, we are not able to give it to anyone. We got permission to just use, to visualize it and to show the results, but not to give the data to anyone. But using this, we are able to allow the people, to look at the model at real time and even to control it, and they were walking to the streets and it worked. But we didn't break any of the agreements because what's directly as what we could. We just showed the visualization and the data never left Prague. Yeah. And as I said, we allowed several people, there was like only 3 or 4 people trying it, but everyone who tried it, well, no one complained about the latency. I mean, the latency was higher than you would like, but it's done by the network and we can't help the network latency at all, right? So basically what we do, or what I wanted to show you is our system which allows us to share the visualizations of 2D or 3D models for the research and basically everything you want, which is easily integratable with existing applications. We are trying it or we're testing it with some group of applications we have, but there's basically no reason for it not to work with any other application. We haven't tried yet. Our only limitation so far is using OpenGL, but we are going to get rid of this limitation soon enough, or soon. And well, I always show it because I said it's in San Diego, but we can do it internationally, and even transmission over quite large distances works at very low latency or is usable even over those large distances. Yeah. Okay, that's probably all, and thank you for your attention.
Thank you very much for this interesting presentation. Are there any questions?
Hi. Can you just explain a little bit about this software that you have written, or is this available somewhere, and how it relates? What's the relation between this software, the software that is running in the appliances that SESNet has, the MVTP appliances, and the other software which is called UltraGrid? Okay. That's it.
So if I have 3 questions, right? For the first one, this software, well, right now it's not available publicly, but it's planned to be made available, well, if I'm not mistaken, this year. But I'm not really the one who's deciding about this, right? The second question was how it works with the MVTP boxes, right? Yeah. Well, the MVTP boxes are using some kind of quite simple protocol for communication, and basically the application transforms the data to the format the MVTP boxes want, and then just stream it over the network. It usually includes some processing because we are when it's in a case system, you usually have 1-to-1 screen, or at least 4-to-3 aspect ratio. The MVTP boxes usually need widescreen resolutions, so I have to either add a letterbox or render it or cut it or do something with it in the software. But it's just simple processing and then it's streamed. And as for the last question, yeah. It's the main developer of UltraGrid.
Thank you. I'm Petr Holub, and I'm currently the leader of the group which develops UltraGrid. So regarding the relation between this and the UltraGrid, the UltraGrid is open source software and will remain open source software. The packet format which is used by MVTP and by this software is considered proprietary. There might be some software which may be based on UltraGrid in the future, but it will be compatible with the box, but it will be, again, a proprietary solution which enables those users who do not want to have the hardware, direct hardware solution. As for the UltraGrid, as in its core, we will keep it open source. We will keep it open in a packet format. This will not be compatible with the MVTP box in the near future, at least.
Thank you.
Are there any other questions? Thank you very much for interesting presentation.
Thank you.
Our second speaker is Tim Bundy from Janet, United Kingdom. Tim supports the video project within the edu sector and manages the application development team. He will tell us about streaming the Olympics in super high vision with BBC and NHK as an international networking collaboration which will focus on networking challenges of super high vision over IP technology. Tim, welcome.
Thank you, Bartek. Hi, everybody. My name's Tim Boundy, as you heard in the introduction. A lot of the projects that I work on in the applications development team are related to video. We're not exclusively just doing video, but a lot of them are, especially the more exciting ones are. This one, as a relationship with the BBC, has been especially exciting. And I know that my CEO is sat at the back there, has got his eye especially on this because he's got links to the BBC in the past and he wants to know this is going to go well. So don't worry, Tim, it's going to be fine. I should probably clarify the title there as well. I'm increasingly nervous every time I say the word Olympics. And just in case I've done anything wrong here, apologies to the Olympic Organisation Committee because I'm pretty sure I'm allowed to say that we're supporting the BBC and the NHK to stream the Olympics. But just to make this presentation ultra safe, we're going to refer to this presentation as international collaborations in super high vision with the BBC and the NHK. And then after I've done that presentation, I'll tell you that the BBC and the NHK are going to be streaming the Olympics. So two completely separate things there. We're fine. So I'll tell you a bit about the super high vision technology, the international IP routing that we're using to send the stream around the world, the very important error correction facilities that makes this actually possible, and then the experiences we've had connecting some of the UK viewing sites to the BBC to allow the public to watch the content. After that, I'll tell you a little bit specifically about the SHV and the Olympics project and the BBC's plans for the summer. So if we start off about the technology itself, you'll notice that these slides are a little bit of a hodgepodge. There's a lot of different groups working on this project, and I don't claim to be an expert in pretty much 90% of the different technologies I'm going to give you an overview of. So credits throughout this presentation go to NHK, which is the Japanese broadcaster, NTT, which is the Japanese NREN essentially, and the BBC, and Géant as well for helping me gather the information for this. So the technology itself is fascinating. Just to give you a very quick overview, this is HD. So if you imagine you've got 1,920 pixels across the top of your HD picture, which a lot of people have in their televisions at home now. Super high vision is 16 times that. So you've essentially got a big pile of televisions stacked up one on top of the other to provide you with the number of pixels that we can ship around the network to do super high vision. So this is also known as 8K. 4K is a quarter of that, so you could call HD television 2K, just to put them in comparison. So it's an 8K picture. The stats, it's at the moment 60 or 50 frames per second. They're going to be upgrading it to 120. It's 16:9 aspect ratio, meaning it's downgradable to HD quality. 22.2 channels surround sound, which actually makes a huge impact on the performance and is equal in importance to the 8K video itself is the 22 channels audio. I'll show you a little bit about the speaker and microphone setup later on. NHK have got big plans for this. They're looking well into the future, and by 2025 they hope to be transmitting public broadcasts in super high vision. So this all came about because people's televisions are getting bigger. The technology to make bigger televisions is getting cheaper, so a lot of people now will have 40, 50-inch television screens in their front rooms. But of course, the pixels have got to keep up, otherwise there's no point in having a bigger television. This means that you can now get a 4K television, which is very expensive, and 55-inch, but they are commercially available, and NHK are developing an 8K television for your lounge, and I think you can just about buy these. They're something in the region of £100,000. So very expensive and probably not necessary yet because there's very little footage you could actually watch on it. But this technology is coming and I expect it'll be commonplace before long. As televisions get bigger, it's very interesting to think about how you imagine that in your lounge. I mean, I'm sure 5 years ago, 10 years ago, you never imagined you'd have a television as big as you do now. It's very difficult to think of course it'll be this big and that'll be fine. We'll be able to sit in front of it, it'll take up half of my lounge and I won't mind. But that's the reality of what we have now. These screens are going to be even bigger, so the point is that you'll be able to sit closer to it. It kind of changes the dynamic of your living room a lot if you imagine this being in production and actually having one of these in your front room. Where do you put your fireplace? Where do you put the pictures on your walls if one of these things is taking up half of your lounge? But the idea is that you can walk right up to an 8K image. And I've seen the demonstration that was shown in the Internet 2 presentation last year, and you can't see the pixels. It's excellent quality. So when you get the chance to see this live, I'd recommend you go and have a look. I realise I've put these next two slides in the wrong way around, so I'm just going to flick forward to this one. NHK did an assessment as they were developing HD and then onwards to SHV. They did an assessment of the viewing angle and the perception of being there. And you can see this little graph at the bottom here. The induced angle is, the experiment they did was they put people in front of an image and then increased the angle of the image until it almost has your whole field of view, and then shifted the image and watched how much people leaned by to see how much they felt induced by this image. And of course the predictable consequences were that the more of your field of view that was filled by this image, the more that you felt the need to lean to compensate. So the experience of being there is obviously related to how wide a field of view you've got with your image, which means that you can make your screen bigger, but if you still put it further away, there's no point. So what ideally, for the experience of being there, you need a big screen, you need to sit relatively close to it, which means you need a lot of pixels densely packed in there so it still looks like a good quality image. So if you've got an SHV image, this thing, and the BBC are expecting to put them on screens not this time, but possibly later, up to 15 meters across, 600 inches. And the expected viewing distance of this is going to be, well, about 5 meters for the 600 inches, but if you have a 100-inch screen, which is feasible for a living room, you're expected to sit about 2 meters from it. So it really changes the perception of what this will be. It's going to be different to television as we view it now. Here's one of the first models that you can actually buy. It has tiny little speakers around the rim to still provide you with a 22.2 channel surround. So big targets for by NHK. They hope to use satellite broadcasting to give you the full spec SHV by 2020, or at least in Japan. Here's one of the cameras that the BBC has borrowed. That's on top of the BBC R&D centre there. They are actually also developing, NHK developing a smaller camera that's possible to actually carry around. These are the speakers, microphone systems that have been referred to as womble droppings. These are going to be all over the stadium, and obviously you need a huge number of different microphones to generate the different channels. and a huge 8K projector at each site as well. This is actually taking 16 HDMI feeds. Sorry, DVI HDMI. And then the speaker layout in the theatres, so they'll be transmitted in theatres much similar to this. And there'll be 22 speakers around the room, enabling the content to actually place noises in separate positions around the room, which is quite freaky, I assure you, to suddenly hear a noise that's coming from here, that is actually part of the picture you're watching. So the BBC's interest in this is to obviously use it for big events across the UK, one specifically rather important sporting event happening in the summer that you might have heard of. They're going to be kitting out theatres especially for this with large up to 15 metre screens. The idea is that this presentation is not like television. It's meant to give you more of an experience of actually sitting in a stadium and watching it than watching a television feed. So they won't be putting on-screen graphics to tell you the scores, because you'll be able to see the scoreboard clearly enough. So it really is much more like having a seat in the audience. Shipping this amount of data around the world is not easy, but luckily we've all got, a lot of the NRENs here are capable of transporting this amount of information. I credit Géant for these slides. The data initially starts off, the BBC have a connection to Janet. Janet will be shipping the data out onto Géant. And in fact, the next slide describes this a little bit better. NTT, the Japanese network, realized that they're going to have to talk to a lot of different network providers to negotiate the 360 megabit stream around the world. And actually, 360 megabits is a lot less than a lot of people expected this would take. It's quite well compressed. So to negotiate the dynamic networks, they are fortunately working with various dynamically configured network providers around the world. But in order to control them as one, NTT are working on a global network editor, which enables them to provision these networks as one virtual network. So you see the one global network editor works with the persona topology and then can work with the Autobahn network provisioning in Géant, and similar with Internet 2 and the other network providers. And if I show you the next link, you'll see how this is actually going to happen. They're going to use a mixture of bandwidth guaranteed networks and also public shared IP. So within Janet, the SHV signal is actually sharing the public IP, well not public IP, the Janet IP traffic. Once we break out into Géant, the signal is then split onto, three IP tunnels, one going over the IP networks of Géant, Internet 2, this is the bottom half on the yellow, Géant, Internet 2 and Gemnet to Japan, and then also via SciNet, so there's two streams there. A third path is going via the bandwidth guaranteed circuits, the dynamically configured ones, over Géant, Internet 2's ION, Pacific Wave and then Gemnet. So it's quite a complicated network provisioning project, but the three streams are going to be running simultaneously, and it'll be very interesting to see the difference. Interestingly, in the demonstration in the Internet 2 conference, which you can see is the example in the middle there, the Marriott demo room in the hotel, the IP network actually performed better than the dynamically configured network. This technology is greatly assisted by forward error correction. The stream is actually UDP, so missing packets makes a big difference. I'll show you a little bit into the technology of this. It's part of a transmission security system that has 3 layers for the video. First, to avoid jitter, the IP packets are tagged with arrival time. Jitter's not a big problem because we don't mind a little bit of latency on this. This is live, but still it's 5 seconds is fine. We're not doing any collaborative work, or it doesn't matter if there's a little bit of delay. The data is then encrypted, and then it runs into the forward error correction system to avoid packet loss. So the data then flows across the IP networks, is then forward error correction de-encrypted, also de-encrypted for security, and then packets are put back in order and transmitted to the decoders. A bit more about forward error correction. I barely understand this, I'll be honest, but what basically is going on here, the packets of data, I don't know if I've got a laser pointer here, but you can see the larger blue bar at the top there, if you imagine that as the data split into four packets, A, B, C, and D. These packets are then used using a matrix transform to create packets E and F. So all that data is transmitted over the network. In this case, B and C have been dropped, but they can then be recovered from running the matrix in reverse so that you can recover what B and C would have been from E and F. This is scaled up dramatically, and these packets, A, B, C, and D, are increased in size because of the relationship between the larger packet size making it more robust. And this creates a forward error correction system that can actually cope with 10% packet loss before the signal degrades, which is very impressive. And luckily, we've never had to actually use the full 10%, but it's impressive nevertheless. So this means that the actual SHV signal itself, 100% of it is 300 megabytes. By the time you've put it into the encryption service, the FEC, and then split it into two paths, it's greatly increased, 120%. These are sent over two different IP streams, which often choose different paths to increase redundancy in case one of the paths has more packet loss than the other. They then converge back into the forward error correction and are decoded on the other side. The most, we've only managed to break the forward error correction a few times when we've had significant packet loss, which is usually related to network maintenance or somebody treading on a cable somewhere, or these types of things. And at the moment, the connections are running actually with no packet loss. So although the forward error correction is great, we're actually not using it because we're not losing any packets, which is wonderful to know. So, Janet connected sites. Janet's connecting a theatre in Glasgow and in Bradford, in addition to the two sites in London that are going to be showing the SHV feed. Glasgow is one of the BBC sites, which we've installed a connection for. So they're going to be installing, oh, hoping there was a picture there, it must be later on. They're going to be building a theatre in there. The connection for Glasgow has been quite complicated. We've discovered a lot of niggling little things that you only really discover when you start using UDP Trackit, and every packet absolutely has to arrive in order. We've got 10 gigabit connection from the Janet core to the local site, and then the last mile is provided by BT, which is 1 gigabit. Initially, we had some problems because the BBC thought their fibre in their building was a different mode to the one they specified, so that caused all kinds of problems. We then found an interesting issue with Grid. This is a supercomputing network that use Glasgow University as one of the nodes, and they've been working with CERN recently and downloading huge amounts of data, and their traffic is bursting back and forth between nothing to 5 gigabits a second, flicking on and off like that as they download and transmit the data. This plays havoc with the analysis card in one of the Cisco routers, and it took a long time for us to work out exactly which part of the router it was that was causing this problem. Now it's identified, it's fine, and we're flowing alongside the grid traffic without losing any packets, which is a great relief. You can see here some of the bursts of the grid computing traffic and why it was such an issue. It's basically the analysis card couldn't cope with that faster change in data rate and was causing what I believe are called thrusts and flushes. The spike there is one of the biggest peaks, but they're actually running even more now for some reason. So it's actually 5 gig, almost 5 gig. The other site is Bradford, the National Media Museum. They've got quite a few theatres there, and they're used to showing a lot of content, so we didn't build the theatre specifically for this. The connection to there was a bit more complicated, but the solution was different. If the solution for Glasgow was get clever and really understand the routers, the solution to Bradford was to look at the network that's providing it and work out what was going on. Leeds University, who managed the regional area network called YHMAN, connects to Bradford University, and then there was a 100 megabit connection to the Media Museum. So the first thing we needed to do was to upgrade the connection to the Media Museum to a gig. the way that routing works, as I'm sure most of you understand far better than I, is that the 2 times 1 gigabit connections there, you can see connecting Bradford to Leeds. The SHV traffic, because it's 2 single streams, they're actually only going to choose one or the other of these connections. So the fact that they're already running at 40% each means that you can't actually use all of the bandwidth available there. It's going to be determined by which connection the IP traffic picks at the time. So we found that we needed to increase the number of 1 gigabit connections between Leeds and Bradford. Luckily then, this connection was due an upgrade anyway, so we skipped straight to the I think your computer might have crashed. I'll carry on talking. Do you want to? Okay. Whilst you fix it, if you want to. We've got loads of great pictures. I don't know. We can start again. On track. Okay. Oh, there we go. We're on the next slide anyway. So we upgraded the Leeds to Bradford connection to 10 gigabits. We then made all of the original National Media Museum traffic back onto their 100 megabit connection. So we've actually got a dedicated 1 gigabit line back to the core at bare minimum to carry the SHV traffic. This clearly made it a lot easier and means that we're easily able to transmit the data to the Media Museum without losing any packets at all. So that was, and obviously all those different connections took quite a while to achieve. Right. This is now obviously a completely separate presentation, and Janet is not supporting the Olympics in any way. We are, however, helping the NHK and the BBC with a sporting event they happen to be involved in. The BBC have always tried to do something interesting when the Olympics come along. This is 1948, when the Olympics was last held in London. The BBC were at the forefront of the television technology at the time, and this is one of the first ever outside broadcast vans that was produced specifically for the Olympics to take all the technology to the different sites. NHK have also been involved at the forefront of technology, of television technologies for a long time. In 1984, they filmed the whole of the Olympics in the first HD cameras. Unfortunately, the only people able to watch the Olympics in HD in 1984 was 2 guys in the back of a van. So since then, I believe some people have watched it in HD, but at the time it was of relatively limited use. So this was one reason why the BBC and NHK were very keen this time to make this a public event and to invite as many people as possible to see the content. So super high vision came along. This is also called super HD in some cases. There have actually been 3 different technologies called HD, by the way, which if you go back through the past, makes you wonder why we keep using the same term for different resolutions. So we've connected sites in Glasgow and Bradford to stream the Olympic footage to. The Olympics are also going to be shown on the BBC's network at 2 sites in London. So as I mentioned before, Glasgow Pacific Quays, this is basically a television studio, and we've built a theatre inside it. The Bradford Media Museum already has theatres. You can see there. Now the theatre needs several speakers added, which you can see quite a lot of speakers. In fact, you have to build a whole rig to carry this. So this is all a temporary construction. The new broadcasting house, which is the right-hand side of the horseshoe-shaped building there, which actually just opened a few weeks ago. It's an amazing construction. We're going to be using the old part of broadcasting house, which has been around since the 30s. It's a beautiful Art Deco building. And the theatre in there can hold 150 people, I think, and it's going to be a great place to watch the Super High Vision there as well. So there's 3 public viewing sites. There's also a 4th site at the Olympic Broadcast Centre where VIPs and broadcast executives are going to be able to watch the stream as well. So we've done the testing. All the sites have now been signed off by the BBC as working. We're internationally testing now. The stream is going around the world right now, and NHK are receiving the data. The cameras and the viewing equipment will be arriving in the UK in July, and we'll be installing it in the theatres and putting the cameras in the first sites. The games are going to be from the 23rd of July until the 12th of August, and there will be SHV streams every day showing up-to-date content. The streams will start from about midday. There'll be 7, and each one of these streams will be updated from the previous one to try and keep the content as live and fresh as possible. These are either open to the public or given to sponsors and companies involved in the projects. So, as I was saying, the highlights of the last few hours will be edited on the fly and then put into the latest sessions. Interestingly, the actual camera and the content has given the BBC some interesting production challenges, because making this footage is a completely different technique to making usual television experiences. The view means that you don't have to move the camera. You can actually lock off the shot of the whole stadium and allow people to edit the footage themselves as they watch people run around the track, giving the viewer the experience of actually being sat there. Of course, because they've only got a limited number of cameras, you can do this, they can't really switch back to the studio for some commentator analysis. So it really is quite a pure viewing experience as if you were there. The cameras are going to go to various sites during the games as the different events take place. So the feed, which they're referring to the different world feeds throughout the event, are going to be slightly different as they go. Initially, they're going to start off with some footage that they've already filmed about London in preparation for the Olympics, and about the venues and how excited people are. And then you can see some of the first things that they're going to be showing, swimming. So they're going to have cameras in the aquatic centre. And then World Feed 6, which is towards the end of the Olympics. They're going to have cameras at the athletic stadium, in the velodrome, and still in the swimming pool as well. So these cameras are going to be moving around. Just a quick view of the stadium here and the different camera positions. The little black splodges are all the different options that they've got for where you can have position cameras. These are very tightly controlled. The positions where the SHV cameras are going to be, if you can just see where they're building the screen there, down to the left of that will be one of them. And this position here, in fact, where that photo was taken from, is where they're standing just ahead of the entrance to the stadium in the middle there. That's another position for the camera where you can see that metal construction. I can't remember what that's called, but it's a huge construction in the background. So, I've talked a little bit about the technology, the IP traffic, the error connection technology that's very important, enabling us to do this, the sites we've connected, and the BBC's plans for the Olympics. Thank you very much for listening. One at the back there. Do we have a microphone that we can get to the... Do I have 9 minutes? Is that correct? Okay.
Interesting talk, Tim. Thank you. I'm Rob Munzer with Cybera from Canada. When we were watching the gold medal hockey game, which we care a lot about in Canada, one of the things that popped was that the broadcast was slightly delayed, and you mentioned that 5 seconds was still live. You got lots of time, not a problem, forward error correction, doing good things. But the Twitter feed was actually coming in faster than that, and we knew that the goal had been scored in overtime before we saw it on the live feed. I'm wondering what the general accepted idea of latency is within live, and just how much time you do have to do all that clever stuff.
I'm almost certainly not best qualified to answer that question. In fact, probably the guy sitting 2 places to your left there is probably better qualified. Sorry, you're right. I think that Twitter does add a new dimension to these things, because that is almost instantly live. We're talking millisecond delays on that. The main reason why there's such a delay is the actual processing time of the media equipment in the production end. So, as Claudio will tell you, I can't see you saying it, probably is. Hi. The best way to reduce latency is have the stupidest camera possible, and only one of them. So it's definitely possible to drop this down if the producers, if the broadcasters wanted to reduce latency, but I don't know if they're that driven by that as a demand. So I don't know if I have an opinion on that. Tim, do you have an opinion on that?
Well, of course, you get that experience with satellite anyway now.
Yeah.
So it's nothing new there. But I suspect most people's experience when you go and get into this immersive technology is that, frankly, you'll be so excited that I suspect if you're twittering, the experience hasn't worked.
Yeah, that is one very good solution. Don't tweet. Next question?
Yeah. So you mentioned in the beginning that super high vision is 16 times the screen.
16, yes.
Right. As most of us know, HD itself in television standards cannot fit in a single gigabit Ethernet. So do you know anything about how that is possible? How they managed to get 16 times HD down to 300 and what megabits per second?
300 megabits a second. How the compression works?
Yeah.
I have to admit I don't know how that's possible, but I can put you through to the NHK team, who would be able to tell you a little bit more about that. But I'm sorry, I can't.
Just
answer
curious.
that question.
Thanks.
Any other questions? Easier ones? Oh, Claudia.
Well, as you already said, the stupider the camera is, the faster. The real challenge that the users don't perceive as an experience is that they say network mistake, which we don't think about, but that's what they tell us. So they claim that we are doing the wrong job. So this new technology are bringing us better challenge than
Yeah. You're right. And the microphone arrives as you finish. Yeah.
when you use a stupid and very fast camera, then the challenge goes to the user will complain that that is not there.
Yeah, but I think most users, if you look at, even if you had a network latency of say 100, 200 milliseconds, that's fine when you're just reading a tweet and watching the screen. So most users would be quite happy with that and not notice. But of course, the techniques you're using it for, it's still quite important. Got a question down the front here. I'm not sure how many. I've still got a few minutes left.
Thank you, and Oil Internet too. Will you be surveying the users sitting in those venues watching? And I maybe ask for a reason, because we have so much experience and data that for the most part when we netcast events, people don't watch. And we're not sure why. Is it just because they're not that inspired to watch on their laptop? When people went to the Philadelphia Orchestra netcast, they were much more enthusiastic because it was such a great presentation, and what you're describing for the viewer venues sounds spectacular. But I'm just curious if there's any way to survey, ask some good questions from the people who show up at those three venues that are watching that phenomenal experience to just kind of capture something about that.
Yeah. I don't know of any wider plans to get general user experience. It would be very interesting to do. I think that NHK are going to be following up their research on the feeling of being there. Ask people what they felt about that. But I don't know if the BBC will be doing a survey or not. It's interesting because obviously there'll be thousands of people watching this, so it would be a great opportunity to gather some information. I will ask that of the project group next time I see them. Thank you. I can hear you. I'll repeat the question.
Okay. So just a comment to that question, because nobody answered about the compressions correctly. From what I've learned from HK folks at Internet 2, they're using H264 in 4.2 profile, basically. And they're using a stack of hardware encoders that are tightly synchronized using a general, basically. So this is how you get that huge 24. Basically, you get like 24 gigabits per second of raw data if you're using pre-wire pattern before the dewirization process, and you just squeeze it into like 300 megabits per second.
I think I'm following you. So it's H264,
4.2 per file.
4.2 per file. Okay. Thank you for filling that in. Any more questions? I think I've almost run out of time there. Okay. Thank you very much.
Thank you very much for this interesting. The from Federal University in Rio Grande do Sul from Brazil. Is it on now? Okay, so Walter from Federal University of Rio Grande do Sul. He is a professor and researcher. His experience in computer networks, multimedia, video encoding, and network transmission. Walter will tell us about MConf, towards a global web conference system. It's a proposal for a flexible, distributed and scalable and federated global web conference system with mobile access.
Thank you for the introduction. Good morning, everyone. I'm here representing Clara Network. Clara is the cooperation of advanced networks of Latin America. It's an equivalent to GEANT in Europe. And this project is sponsored by RNP, which is the Brazilian NREN, and sponsored by Red Clara. In the project Alice, sponsored by Dante. The idea, let me first talk about the title of the presentation. Towards a global web conference system. So I will present the MConf web conference system and try to show you that it's ready to a global collaboration in an open source web conference system. So MConf, in short, is composed of three main entities. The first one is the MConf web, is a web portal on the top. We have here the MConf web. Big Blue Button web conference system. Our group do some developments in the core of Big Blue Button. In fact, Fred Dixon is from Big Blue Button Corporation. He's one of the authors of this presentation, this paper. And another entity is MConf Mobile, which is an Android application. So this is the web conference system. I think all of you know what is a web conference system. I think everyone here knows Adobe Connect, and most of you knows Big Blue Button. There is some video conference pod and presentation pod and chat pod and notes pod and participants and so on. I will not talk about that. There is a web portal which is mconf.org, where the user registers. It's free. The user registers, and he gets a permanent room. So it just clicks a button and he's in its room. He can invite people through an URL. Today there is communities, lots of communities. It's very easy to create a new community. There is scheduling, invitation. Well, this I think you know. Today there is approximately 500 users and 200 communities. And there is the Android application, which is, well, a video conference in mobile. I think everyone knows it for sure. So what? Here is the point. I think what you are thinking, okay, yet another web conference system. What I am doing here, why this guy is doing up there. Why it has potential to reach a global scale. So that's the question I intend to answer right now. Well, the first problem to reach for a web conference system to reach a global scale is scalability. Scalability to reach thousands of users. So thousands of concurrent users in different rooms. So this is a big challenge. How can we offer a system to cope with thousands of users, simultaneous users? Well, the second problem, if you want to launch a global system, global web conference system, is that the institutions, the NRANs, want to keep their visual identity. They do not want their users to go into another system, another web portal to reach a service of web conference. They want their users go to their portal. So it's another big problem. So to talk about this true solution for these two problems, I will show the mconf architecture, which is composed of lots of servers. These are big blue button servers with our modifications to cope with scalability. So these servers send information of CPU usage, memory usage, bandwidth usage to a Nagios monitoring server. And there is a load balancer, we call it mconf load balancer, which retrieves the statistics from the Nagios server. So this is happening on the background. When a user enters any portal, it can be the NRAN, Brazilian NRAN called RNP, web portal, or mconf web portal, or Red Clara web portal, or any of your country or NRAN web portal. The user clicks in a join button. I want to join a conference. And this sends a message to the load balancer, who chooses among these servers which is the best, based on a sort of heuristics, and redirects the user to the most suitable server. So the user joins the web conference. The other people who will be in the same room joins the same server. So that's the basic architecture. This approach solves the scalability problem because it allows thousands of users and servers spread in different regions, cities, countries, continents. Solve the identity problem because user can access the web conference rooms through their own portal. And on the top of that, it is open source. So how to test that? We implemented that. It was ready about a month ago. We are beginning to test, and our problem was, how can we test a system with hundreds of users simultaneously? So we created a command line bot in Java, And there is the name of the meeting, the name of the room, demo meeting. There is a video in loop that keeps going in loop, an audio that keeps going in loop, an interval to launch each bot. In this case, it's 500 milliseconds. The probabilities I'll talk about right after this slide, and the number of bots that I want to launch. So the probabilities of distribution of rooms we got from the database of Brazilian and Iran during 6 years, and we discovered that the Brazilian and Iran behave like this pie graphic. The room size of 2 users, it's about 58%, 3 users 20%, and so on. So we used this distribution here. 2 users in the room, 58.68%, 3 users, 20.82%, and so on. So we right now we have mconf today. We have one server which is the load balancer, and 2 servers, one in Brasilia, which is a city, the capital of Brazil, and another Big Blue Button server in Porto Alegre, the very south of Brazil. This is about, I don't know, 2,000 kilometers or so. I will show you the load balancer. You can try it, it's open. The load balancer is here. We have right now the number of users in all servers. We have 2 servers, so we can see that we have about 100 users. The room distribution of this we have about 34 rooms distributed in 53% with 2 users, 29% with 3 users, and so on. We can see in bars or pie. So going back here with 100 users, we have these other graphics that shows the statistics per server. In this case, this graphic shows the current CPU, which is balanced among these 2 servers, mconf.org and WRNP2012. The available memory, you can see that the machines are different. You don't need to have the same kind of machine. This one has 4 gigabytes of RAM, this one 8 gigabytes. And the bandwidth in and out, and number of users. This machine is a little more powerful, so it is serving more users than this other machine. That's it. I will go back to the presentation. If we increase the number of users, the CPU load of both servers will grow equally. In the beginning of this month, I was in an workshop in Brazil, and we were with 4 servers, and we put about 500, little more than 500 users, and the 4 CPUs were in about 50% of load. We could easily put 1,000 of simultaneously users within these 4 servers. So the idea is to have the servers in a cloud system, for example, and if you want to grow the number of simultaneously users, an intelligent system can sense that and create automatically a new server in a cloud or something. So the mconf is ready for federation. It's ready for integration in the CAFE, which is academic community federated in Brazil. And CAFE Federation is part of EduGain, so it is ready for enter the federated global network. So in short, mconf today is a development work group in Latin America with partnership of Big Blue Button in Canada and potential to be used and have servers globally. How is that? What's the proposal? How can we do a global collaboration network of web conference? I took this image from Planet Lab, but it's an example. It just shows an example scenario of lots of servers distributed worldwide, and each server is connected or sending statistics to the load balancer. And the users are distributed among the world and using the most suitable server. So the fee to enter the global web conference, this is only a proposal, it's not ready, but the idea is that the fee to enter the global web conference network is to offer one server, can be a virtualized server. So this server can be administered remotely by the mconf group if you want. If not, you can administer it yourselves. So the cost is practically zero. What's the advantage of this system? Well, high availability. Why to have a global integration? Why is that? Well, high availability, even if a server fails, there would be many others, so your country can offer one server, but if the server fails, you won't let your users down. Optimization of resource. The idle servers during the night in one country can be used by other countries and vice versa. Low maintenance cost. The maintenance of one or more load balancer is performed by our team. If you want to have a load balancer on your own is okay, but for the country is practically zero cost. The dashboard, on the other side, you can see your users using the system, you can see statistics, you can see everything what's happening in the world and with your users. So there is another advantage is that the system proposes a global collaborative environment. So more programmers improving the same tool. This makes perfect sense because it's time for the world to collaborate in the same video conference, web conference tool, which is open source. And there is thousands of little things to do in this web conference system. The people who run Big Blue Button knows that. There are hundreds of big things to do, like integration with Room Video Conference, H323, SIP, and lots of things. And if the world collaborate with the same tool, this development will be ready much faster. Well, the final message is, if it is so simple, why not? Why not enter the conference? Why don't give it a try? So I'm proposing for you to give it a try. You can enter, offer one virtual server or one physical server. We can put the system. You will not have any work to do. If you want to use your users, use mconf.org. But if you want to your users use your own portal, you have to create a system that connects and send messages to the load balancer. So questions? You can send messages to me or mconf at mconf.org. questions? No. Okay, thank you. He told that there is another benefit, that is the architecture itself. It's suitable to protection against denial of service attacks and things like that. The architecture is very simple, yet very efficient. Thank you. They're changing the batteries of the microphone.
First of all, congratulations for your work. It looks impressive, and it certainly shows that you have put a lot of very much effort into this, making Big Blue Button and all the other components work like this. I just wanted to go into your proposal for federating this and making it scalable to in terms of a multi-domain service in different NRENs or Giant and Red Clara and other continents. Okay. So I think the only obstacle I can see there is that you have the load balancer, which selects where to start a new conference, and all the users of all the participants in the particular conference will go to that particular Big Blue Button server. This one, that part is not federated, so you can connect your Big Blue Button servers, which can be whatever, but they all have to be controlled and monitored, and resources have their resources allocated by one load balancer, which is unique. Is that so, or do you have any plans for that? And let me just start a second small question to that. Considering the amount of work that has gone into this and how promising this looks, I know that Big Blue Button is Flash-based, and we all know that there are some challenges and risks involved with that. Mm-hmm. And the question to you is whether, beyond the practical point of using something that works today, such as Big Blue Button, have you considered using something else? For example, there are technologies like WebRTC, maybe, which could be a good candidate replacement for Flash.
Well, thank you for both excellent questions. The first one, we intend to do a distributed model for load balancers, like DNS. When you enter when you configure your computer, you put two DNS servers. You can put two load balancer servers. If one fails, you can go to the other, ask the other for to choose the best Big Blue Button servers to enter. So this is one thing that is not ready yet, but it's very easy to implement. And the other question is about the Flash. We did not have time to create a server and a client, but we intend to go to HTML5, which I think it's the most promising platform today. But it's only a matter of effort, team effort and programming effort to change that. And when we change to HTML5, we will have to change the server also. And but it's part of the game. You can use it right now, and you go evolving the system. And if it's global, you can evolve it together. That's the idea. Okay.
Yeah, well, maybe the big blue button will change also. One question to the load balancer. If you plan to take into account the location of the users, I mean, if they are coming sort of asynchronously to the room, that's a problem. But whether you can choose from the user side whether to stay in Europe or something like that. The situations where there are 10 users all sitting somewhere in Europe and using the server in Brazil would be probably a little bit problem, adding additional delay to all the audio and video.
Yes.
And the second thing is, how do you plan to deal with content, uploaded files and recordings and this kind of stuff? Whether you plan to do some shared cloud drive service or something like that to store these out of the big blue button machines really running the service itself?
Well, the first question is about the servers. Certainly, right now, as I told you, we finished the implementation about 1 month ago. And this implementation, it's very simple. It's just balance through CPU or memory or bandwidth or number of users. It's only that. But we need to go in some more smart heuristics to create some kind of delay related system, because maybe if the users are in Iceland and there is an available server in Colombia, it's better to use a server which has more CPU load here than there, because of the delay. So it's not so difficult to implement this kind of thing, and it's in the roadmap to do that. The second question, sorry, I forgot. Just remember. The content, yes, thank you. The content, we intend to keep them in the web server, not in the big blue button server. It's a different model than Adobe Connect, for example, that keeps the content inside the room, inside the server, the Adobe Connect server. We intend to keep the content, the presentation, the additional elements of the web conference inside the web portal, and the recordings also in the web portal. So if the user wants to record the session, it can get a link to the web portal, and it's available there afterwards. That's the idea.
Thank you very much for this presentation. I have three short announcements now. There are demos during the breaks. Please check the up-to-date online schedule and go to see the demonstration. Booths and workshops are starting today from 6 o'clock, and there are also poster